So again, good afternoon. We're going to continue solving some linear equations. And these are going to be a little bit more advanced. Notice how some of these will have what we call a variable on both sides of the equation. So, what I tried to identify are a little checklist of things you can do to maybe work your way through problems of this nature. So, let's look at the first equation. I have 13 minus 4 times some number has to equal 1 minus that same number. Well, the first thing we pick up on is we have to simplify each side of the equation, which means if there's like terms to combine those like terms, or if you see those parentheses, you can use that distributive property to remove those parentheses out of the problem. So if I look at this problem right here, I really can't see any like terms on this side nor this side, and I don't see where there's a need for the distributive property. So step one doesn't really exist in this problem. So next thing we do is we get the variable on one side of the equation. And what we do is we pick on the little guy, and what we do is use the zero pair. So since there's a variable on each side of the equation, what I want to do is pick on what we call the little guy. So looking at the variable part, I see this negative 4x and I see this negative x. Negative 4x, to me, is a little bit smaller because there's 4 negatives. Remember, more negative, the less value you have. So I consider the negative 4x the little guy. And what I want to do is use a zero pair to knock him out. So if I have a negative 4x, what I want to do is add a 4x. But remember, since this is an equation, you've got to do that to both sides of the equation. And I want to put that 4x over by the x because those are like terms. So that negative 4x and positive 4x are going to zero out. This 13 would come down, equals then. This 1 slides down, and if you have a negative x and 4 positive x's, that's going to make me lose an x. So I'm going to have then 3x's left over there. So I have 1 plus 3x. So now notice how I have the variable on one side. And right now you can kind of start using this balance of the scale thing. It's clear this side's 13. 1 plus 3 times what? What can you add 1 to get a 13? Well, this would have to probably be a 12. 3 times 4 is 12. 12 plus 1, that's 13. So I'm thinking probably using my reasoning skills that 4 should be the answer. What we can also do is go ahead and just use our strategy of getting x by itself. We want a zero pair and save that multiplying and dividing for last. So to get x by itself, I want to get this 1 out of the way. So I zero it out with a negative 1. A negative 1 each side. You have 12 is equal to then 3x. So I'm going to rewrite this over here. 3x equals 12. Don't have enough room. And to get that x by itself, see I have multiplication there. That multiplication tells me I can divide each side by 3. Those 3's divide out. And I would indeed get 3 into 12 would be 4 times. So 4 would be my solution. And that should check out if I substitute back into the original problem. So we just got a few more steps layered, but the bottom line is we're really working our way back to something we're more familiar with once we get to here. So let's look at example number 2. And let me put a little asterisk by this one. So that 5 plus 4x equals 4x plus 5. Again, combine like terms, distributive property, that's my first move. But the left side, 5 and 4x are not like terms. Over here, 4x and 5 aren't like terms. I really don't see any parentheses to be using the distributive property. So what I'm moving down to is my next step. Get the variable on one side. Pick on the little guy. Well, they're both 4x, so it really doesn't matter since they're the same. So I want to go ahead and just zero out the 4x using a negative 4x. In doing so, what I end up with is 5 is equal to a 5. So the variable actually falls out of the problem. In other words, the variable just zeroes out of the problem. When this happens, this is what we're looking at. If the variable zeroes out, the solution will be all numbers for a true statement or no solution for a false statement. So once the variable zeroes out, you look at this statement we have left. Does 5 equal 5? Is that a true statement? Yeah, 5 does equal 5. Since this is a true statement, our solution would be it would be all real numbers. So we would write down all real numbers. So what this means is it doesn't matter what you pick for x, this is always going to be true. Because it's a true statement already. You have the exact same thing on both sides. So your scale is already balanced. So it doesn't matter what you pick, you got to pick it for the same, you have to pick the same number for each x, so you can't say x is 2 and x is 3 over here. Whatever you pick for x over here, that same value has to go over here, so it's going to remain a true statement. So what this is telling me is all real numbers would be my solution. Let's look at example 3. So again, we look at simplify each side equation, combine like terms, distributive property. I don't see like terms over here, but over here notice that you have an x and a negative 4x. Those are like terms. So I'm going to bring down this negative 8 minus x over here, but an x and a negative 4x's, that's going to leave me 3 negative x's. So that positive x is going to knock off one of those negative x's. So I'm left with 3. Remember, you can also work with the coefficients. Remember, there's like a 1 there. So if you have like terms, a 1 and a negative 4, a 1 and a negative 4 would give me a negative 3. I have a negative 3x there. So if you want to look at the coefficients, you can do it from that thinking. So now I've simplified each side. So step 1 was involved. My next move is to get the variable on one side. And again, I want to pick on the little guy. So I have a negative x and a negative 3x. To me, a negative 3x is smaller, so I want to zero him out. So I add a 3x over here, but also got to add 3x over here. So what I have then is a negative 8. This becomes a positive 2x equals, and that's going to zero out, so I'm just going to get a 0 there. So now I have negative 8 plus 2x is equal to 0. If I want to continue on now, I've done that. My next step is to get x by itself. 0 pair. That goes for that negative 8 part. So I have to zero that 8 out with a... That negative 8 can be zeroed out with a positive 8. But if I add an 8 over here, I have to add an 8 over here to keep it balanced. The negative 8 and positive 8 will zero out. 2x is going to equal 8. And there you can probably start to see the answer. You know, 2 times what number is going to be 8? 2 times 4 would be 8. So my solution is going to be a 4. If I want to carry out the math a little bit further, I'm going to rewrite that so it's up a little bit higher. So I'm going to run off the board down there. So if I divide each side by 2, those 2's divide out, and x would indeed give me my 4, and that would be my solution. Okay? So that gives us a little bit of a lead into solving linear equations that are a little bit more difficult, where there's a variable on both sides. Notice again, it's important to get that variable on one side if we're trying to find that solution. So stay tuned.